So can somebody read us our two objectives, please? Our two objectives. Paul, go for it.
Solve an equation containing only one variable and isolate one variable in formula.
Okay, so we're just solving an equation in one variable, which you've seen before in basic algebra. What we're going to do today is we're also going to look at how we can solve equations for variables when it's all in terms of other variables. So without any numbers at all. Okay, so we'll look at all algebraic solutions for some of these. All right, so we're going to start with a little definition here called a root. Okay, and a root is any value of a variable that makes an equation or a statement true. What's another term for this? What's another word for root? What is it called when you find out what the variable should be that makes the equation true? What have you called it in the past? Have you all called it roots before, or have you used other words? Solution. Answer. Result, like that kind of thing, right? When you're solving that variable. Just a term to know. Okay, we're going to use the word root a lot. So when you hear root, it's what makes the equation true. Whatever makes the equation true. Take a look at our first example here. Who wants to step us through what you do in this problem? How would you go about a problem like this? Niall, go for it. I'm going to shut the air off so we can hear you a little bit.
You would distribute first, so you get 6x plus 15 equals negative 7x plus negative 63.
I'm going to put minus 63, which is the same thing, right?
Oh, right. Yeah.
Same thing. You can put a plus and negative, which is what we just said. Continue.
And then you could subtract or add 7x to the 6x.
Now, I would agree. Why wouldn't you move the 6x over? Because you could do that also, obviously. But why would you choose? You're right. Why would you choose to move the 7x over first?
It's easier to have positives.
Yeah. Make it easier on yourself. Whenever you can possibly do it, try and get the variable to have a positive coefficient so you don't have to worry about negative in the end or dividing by a negative. It's just easier with positive numbers. So as I said, let's add 7x. Right? Add 7x to both sides. This is the addition property of equality that we talked about last class. Whether or not you realize you're doing it, you're adding the same thing to both sides of the equation. That's what the addition property says we can do. Keep going, Niall. What do you get?
And then so you have 13x plus 15 equals negative 63.
Yeah, these cancel, remember. They just drop off.
And then you add 15 to negative 63.
I'm going to add it.
Or subtract.
Okay. Why am I subtracting? Just so we're clear.
Because it's the opposite.
Yeah, it's currently being added. Right? 15 is currently being added, so to move it over, we subtract it. Still the addition property of equality. You're just adding a negative number now. Okay, giving us 13x here, right? Canceling these two. On the right-hand side, our rules of numbers we just said. Make believe they're not negative. Just add the positive values together. It's easy. It's 78, right? And then just tack on the negative sign. Don't let negative screw you up along the way. Okay, so negative 78. Keep going.
And then you divide negative 78 by 13.
Okay, what do we get? Negative 78 over 13? Negative 6. Negative 6. Good. So divide by 13, divide by 13. X equals negative 6. How do I know that this is right? It looks like it's right to me, Nina. Yeah, substitution principle. Take that value, substitute it back into the original equation. If you get the same answer on both sides, then it is indeed a root. Okay, this is the root of the equation. Have you seen? Yeah.
Do you want solution sets or not?
If you want to write in solution set form, that's fine. So solution set form in this case, I'll just say this. Okay? So you can write it that way. Solution sets are important when you have multiple solutions, right? When there's only one solution, I recommend you just leave it as x equals whatever it is or y equals. But when we get to quadratics and there's multiple answers, that's when you want to use your braces in solution set form. Okay? Yeah, good question. All right. We good on the first one? All right. Let's fly. Okay, work on it on your own. Solve this one on your own. Think outside the box. You're going to get a funky answer. You know, this one's wrong. Sorry. On the third one, you got a funky answer. Yeah, I think it was four. Oh no, you do get a funky answer for this one. Check your work again, Kel. Once you get to the last line, make some sort of a statement, whatever you think the result actually means, because this is a little bit of a different problem here.
This one?
Say again?
Just this one?
You can go on to the next one if you finish, that's fine. I'm going to talk about this one in a second though. I'm just trying to give everybody time. Did people all get to this point in time right here? Right, for the second one? And then what do you do with the three H's? What could you do with them?
Cancel.
Yeah, they cancel. So as a result, what do you get?
No solution.
Yeah, no solution. It's called the contradiction. Is that true? It's clearly not true, right? The statement here is not true whatsoever. So you call this a contradiction, and there's no solution, or it's an empty set. Okay, so you can write this as no solution, or you could write it with an empty set symbol, or with an actual set that's empty like that. Okay, either way, any way you want to write it like that is fine. In math, when I was a student, we used to call it a null set, N-U-L-L, null. Same thing as empty set, but just so you're familiar with the terms. Your book might use the word null set, so just keep that in the back of your mind. Any questions on this one? If you made a mistake along the way, did we figure it out? Did we correct ourselves, if so? Okay. A statement at the bottom as to what you think it really means now for this one. Okay, when you get it, write down the statement at the bottom. Ben, why don't you step us through this one?
Okay. First, I distributed the 3.
Okay, giving us.
So it made 6m minus 9. And then I distributed the 6. So it was 6m plus 6 minus 15. And then I switched over to make it 6m minus 6m. And then 6 minus 15 plus 9.
So you just move things around?
Yeah.
So Nick moved this 6m over, and he added this 9 over here in one step, which ends up looking like this. Right?
Yeah.
Which gives you what?
0 equals 0.
0 equals 0, which is different than the last problem, right? Last problem it was 8 equals negative 8, which was not true. But isn't this true? So Ben, do you know what the result would be?
All real numbers.
All real numbers, very good. Any number works. Any number works. Now, you can also, at this point in time right here, had stopped. Because watch, this is really just negative 9 together, isn't it? Isn't that really negative 9? And you get 6m minus 9 equals 6m minus 9. As soon as you ever get something where both sides are equal, it's all real numbers. Okay? Good. Very good, man. So all real numbers. How do I write all real numbers? How do I write m is in the set of all real numbers?
Well, you do like the R, so it's like the weird R.
So m is in the set of all real numbers. Okay, it's like a double R. You put 2 slashes in the front, and then the rest of it is normal. Okay, m is in the set of all real numbers. Okay, let's take a look at an example from physics. So, Has anybody ever launched rockets before? Like build your own model rocket as a kid and launch them? We're doing it this year actually with the senior engineering class, but we're building them a little bit more intricate than when you were kids you would do it. But this is indeed the formula you would use. This actually is. Anybody know where the 16 comes from? Anybody know where the 16 comes from in the front? It's kind of weird. So in physics, the gravitational pull in metrics is 9.81 or a metric system, but in the English system is 32.2 feet per second squared. Well, if you look at the formula in physics, and Nick, you probably remember this, it was 1/2 AT squared, remember last year? So 1/2 of 32 is actually 16, and acceleration is always down. So this negative 16 comes from the Earth's gravitational pull. That's what that is. V0 is initial velocity. Okay, V0 or VI, depending on which physics you're in, sometimes they're named differently, just means initial velocity. So the velocity of the rocket as it's launched, okay, that's what V0 really is, and the negative 16 is the acceleration pulled downward. Now the formula that gives us this relates the height with time. Okay, the height with time. So I'm writing it as h equals because we haven't really studied functions yet, but really we would think of this as h as a function of time. Okay, you could really write the formula like this as well. I'm not putting that yet because we haven't talked about functions, but for those that are familiar with functions, that have seen them, that's how you would really write it, because h, the height of the rocket, is a function of time, because it changes height as time changes. Now, we take a look at this equation. We're told to determine the initial velocity. Find the initial velocity of the rocket if it reaches a height of 40 feet after 2.5 seconds have passed. So for a problem like this, what do I do? What do I do for a problem like this? Now, go ahead.
You plug in the numbers.
Yeah, we just plug in the numbers, right? Let's go ahead and plug them in. Go.
V40 equals negative 16. I had 2.5 squared
Okay.
plus VL 2.5.
Very good. And the only variable now is V, or VO. So we could solve for VO. Okay, make sure you square this first, then multiply by negative 16, then move that quantity over, and finally at the end you can divide by this 2.5. Okay, solve this like any other algebraic equation. Are we clear on that? Now, before we go to the next problem, let's talk about solving generically. Solving generically. So if I go back up to this line right here, I go back up to the boxed in line right there, and make believe I didn't know what the numbers were. I was not given 2.5. I was not given 40. And I ask you, come up with an expression that represents V0 for any other values of h and t. Come up with an expression that represents V0, or in a sense, solves for V0, without even knowing those other numbers. Who could tell me how to do this? Want to start us? Good. That's the quadratic formula if you were solving for t. Okay, I'm asking you though, solve for V0. Solve for V0. Well, go back up to the previous line. Right? Once you square the 2.5 and multiply it by negative 16, wouldn't you just add that over here? Yes? Once you have this number and it's this a negative number, you would add it over. Isn't this a negative quantity? How do I move it over to the other side? Add it over. So what do you have in the next line? What would it look like in the next line?
H plus 16t squared equals V.
Yeah, right? This is the same thing. Right now, I'm performing algebra the exact same way I would a moment ago. Again, I would have gotten a number here. It would have been negative, and I would have added it over here to 40. So you're literally doing the same thing, but without any numbers. Then, at this point, you would have probably divided by this 2.5 to get V0 by itself. Right? That's how you would have solved this. Once this number was over here and you added like terms, you would divide by the 2.5. So, what will we do now? Instead of 2.5, because I don't have 2.5, I still have a variable. What should I do, Nina?
Divide h plus 16t squared by 2.
Yeah, divide both sides by t. And lo and behold, you get V0 by itself. This is the expression that represents V0. The t's cancel when you divide over here on the right side, and you've solved what's called generically. What does generic mean? When you get, like, anybody ever go to the doctor's office or get a prescription filled? They'll say, do you want the generic or do you want the regular or whatever it is? What does generic, that term actually mean?
Like it's not like for specific, it's for like something, like it could be anything that has those.
Yes, it's not specific at all. It's an overall or a global or a holistic solution. It's a solution that works in all cases. So this is the answer for the initial velocity. It doesn't matter what the time is. It doesn't matter what the height is. I could say, all right, you know what? Now the height is 50 feet after a time period of 1 second. Find the initial velocity. You plug in a 50 for h, you plug in a 1 for t, and you get the initial velocity. So you're solving for the initial velocity for any possible case, any scenario. That's what generic means. Okay? The answer we got a moment ago, did anybody actually work out the numbers from the previous part? What did you get as a number for zero originally?
56.
56? 56 is a specific solution to that scenario. To the scenario where we had a height of 40 feet and a time of 2.5. The answer we got was 56 feet per second. But the velocity generically is this expression. Okay, you're just rearranging formulas. That's all you're doing there. So let's take that idea to the next problem. Let's take it to the next problem. So, now, I'm writing a little note at the top, but I already discussed what we were saying in that note. But the note says the following. In the next example, when you're solving an equation in terms of other variables, consider those variables to be like constants. Perform the rules you would perform as if they were numbers, pretty much. Okay, so the volume of a cone with a height of h, so let's draw a cone so we know what we're talking about. Right, so a cone is easy to draw. Draw it like an ellipse with two lines like that. Okay, draw an ellipse with an upside down V. So we've got a cone with a height of h. There's the height h along the side of the cone. And a radius of r. The radius is drawn from the center outward. Okay, height of h and a radius of r. And the formula for the volume of that cone is given here. 1/3 pi r squared h. And we want to solve this formula for the following variables. So in part A, let's isolate h. Solve the formula for h. Get h by itself. Step us through it, Kelly.
Okay, so what I did first, you would multiply 1/3 by 3.
Good. So to get rid of a fraction, we're going to multiply by the reciprocal. So Kelly says, let's multiply both sides by 3.
So then you get like 3b. And then you would divide...
What does that equal? Tell me the other side.
Sorry, 3b equals pi r squared h.
Good. That 1/3 cancels. Continue.
And then you would divide pi from both sides of the equation.
All right.
So you would divide pi on the right side, and you would put 3b over pi, and then you would divide r squared.
So can we do that all at the same time?
Yeah.
Yeah, so let's divide by pi r squared all at once. And it cancels the r squareds also. So that's what I'm saying. See this pi and r squared? Think of these as numbers, because we're finding out what h is. So whatever's in front of it is like its coefficient. Pi r squared, that term, is a coefficient of h. So if it were 5h, you would divide both sides by 5. So now it's pi r squared h, so divide both sides by pi r squared. And that is our answer indeed. This is what h is equal to. 3v over pi r squared. Please ask questions if this is confusing, or just tell me I'm really confused and I'll try and explain it another way. Okay, with silence, I'll assume we're good. So let's all try part B on our own. Part B is a little trickier. Part B is a little trickier. Be careful, please. Make sure you think about your properties like associative. You could rearrange stuff. Okay, and think about the fact that r squared. Straight up exam. So close. There's one thing, but actually, technically, it's right. Remember that? But technically, because it's a radius, it's only positive, right? So you don't have to worry about it. But just algebraically think about that. That's good. Very good. Good so far. Good. Keep going. Guys, when you're doing problems like this, if you're struggling at all, just I'm saying in general, you want to work with somebody next to you or just ask for help with somebody, that's totally fine. So you don't have to, sit in silence and do it if you have some struggles. If you notice the person next to you is struggling, maybe say, hey, let me help you with that or something. That's fine. Let me go over part B. It's a little bit tougher. Same approach, but a little bit tougher. Now we're solving for R, right? So let's write our formula. I would start this problem by rearranging it mentally or physically on the paper. I would switch R squared and H, the position, just so I could see it a little bit better. Now you can do this in your mind, or you can do it on the paper. We know we can do this because of the commutative law of multiplication. I could switch the order of any of the multipliers or the factors. Now, after that, once you've done that, we've approached this the exact same way as the previous problem. So multiply by 3 to get rid of the 1/3. It is so loud. Do me a favor, go spy who's next door. Don't even, no, just go walk by the room. Just look in, see who it is. Okay, so we get a 3 there, right? By multiplying by 3 on both sides. Now, in the previous problem, we knew we were looking for H, right? But now we're looking for R squared. So what I want you to do is this. Think of the coefficient here as a numerical value. What would you do if it was like 5R squared, Niall?
Divide by pi h.
You would divide by it. Good, so let's divide by it. So divide by pi h. No, I'll just talk to him after. Thank you. There's only a minute left. I appreciate it. So that's where we're at right now. And it's pretty much the same problem as the last one, right? The last one we solved for h. What do we do now, right? Square root it. Okay, so just square root it. So the square root of this quantity. Now, remember, right now we're looking for the radius. So the answer is definitely, a positive length. But when you take a square root, you should technically put a plus or minus in the front. Because remember, when you square root a number like 49, the square root of 49 is 7, but it's also negative 7. And we'll go over that later in the year as we get to that idea. But because it's a radius and it's a length, it's got to be positive. You can't have like negative 20 centimeters. That doesn't make any sense, right? You can't say this bottle's height is negative 20 centimeters or whatever it would be. So the plus or minus doesn't really matter right now, but just so we're clear as to that. All right, so what do we call this again? What kind of a solution is it? Because there's no numbers. What is it? A generic solution. If I then told you, if I said, well, the volume is 20 and the height is 2, find the radius, okay? If the volume, hold on one sec, was 20 and the height were 2, you would plug in a 20 for the volume and a 2 for the height, and you could just get the radius automatically, okay? First thing we did, the 1,4 to 1,6 should be very quick. This might take you a little longer because you're solving equations, okay? ST means self-test. It's a self-test, like a little mixed review area, okay? Again, please do your homework after your notes, not on the textbook tonight, and upload them to Dropbox.